Have you ever wondered how Mars, the enigmatic red planet, came into existence? Let's journey back in time, around 4.6 billion years ago, to the early days of our solar system. The birth of Mars, like all planets in our solar system, begins with a massive disk of gas and dust, known as the solar nebula. This nebula was a swirling, chaotic mess, a byproduct of the sun's formation. Picture a cosmic whirlpool, spinning and churning with the raw materials of creation. Now, within this spinning disk, something remarkable happened. Tiny particles of dust and gas began to collide and stick together. Imagine this process like the creation of a snowball. You start with a small core, and as you roll it along the ground, it gathers more snow, growing larger and larger. This is how planets are born. The force driving this process is none other than gravity, the universal glue that holds everything together. As these particles continued to collide and stick together, they formed larger and larger clumps, known as planetesimals. Over time, these planetesimals attracted even more material, growing in size until they became protoplanets. Now Mars was one such protoplanet. But unlike Earth, its growth was stunted relatively early. This happened because Jupiter, our solar system's largest planet, migrated inward, disrupting the formation of Mars, leaving it only about half the size of Earth. However, this didn't diminish the significance of Mars. Its red hue, a result of iron-rich minerals in its soil, gave it a distinct identity among the celestial bodies. Furthermore, its geological features in the presence of valleys and dried-up riverbeds hinted at a fascinating past, sparking curiosity and wonder about the possibility of life. So Mars was born out of the remnants of the early solar system, a celestial body of dust and gas that would eventually become our neighboring red planet. And as we delve deeper into the history of Mars, we'll uncover more about its intriguing past and its potential future. In its early years, Mars was not the barren, cold desert it is today. Like a child full of energy and potential, Mars was brimming with geological activity and atmospheric changes. Its surface was a dynamic playground of shifting landforms, painted with vibrant hues of iron-rich minerals. Beneath its crimson crust, Mars was a hotbed of volcanic activity. Among its fiery children was Olympus Mons, a behemoth that would grow to become the largest volcano in the solar system. This colossal giant, standing 3 times the height of Mount Everest, is a testament to the intense geological activity that once thrived on Mars. The Martian atmosphere in this youthful era was thicker than it is today, creating a pressure cooker of sorts. This blanket of gases, primarily carbon dioxide, could have provided a greenhouse effect, warming the planet's surface and possibly allowing for liquid water to exist. And where there's water, there's potential for life. Mars's past is etched with evidence of water. From ancient riverbeds to minerals that only form in the presence of water, these clues hint at a time when Mars was not just a red planet, but a wet one too. Among the most striking features of Mars is Valles Marineris, a canyon system that stretches over 2,500 miles across the planet's surface, dwarfing our own Grand Canyon. This gargantuan scar on the face of Mars is another testament to the planet's volatile youth. But as Mars grew older, its fiery heart cooled and its atmosphere thinned. The water evaporated, and the once vibrant planet became the cold, dry world we see today. Yet the memories of Mars's youth are etched into its surface, a silent testament to a time of fire and water. It's fascinating to think that Mars, now a cold and dry planet, once had conditions that could have potentially supported life. As Mars matured, it transformed into the planet we recognize today, a world wrapped in a thin, cold atmosphere, its surface etched by wind and time. It's a stark contrast to the warm, wet world we explored in its youth. Yet this seemingly inhospitable planet has been a tantalizing destination for exploration, a testament to our endless curiosity. Our journey to Mars began with the first successful flyby by Mariner 4 in 1965, a mission that gave us our first close-up view of the Martian surface. This was a significant leap in our space exploration history, a testament to the limitless possibilities of human ingenuity. The momentum continued with Viking 1, the first spacecraft to successfully land on Mars in 1976. It sent back the first color photos, revealing a world both alien and eerily familiar, a rusty landscape under a pink sky. In the years since, several rovers and orbiters have followed, each mission building on the last, each one unveiling a new layer of Mars's complex story. The rover's spirit, opportunity, and curiosity have all left their tracks on the Martian soil, their findings revolutionizing our understanding of the planet. The latest to join this illustrious list is Perseverance, a rover designed to seek signs of ancient life and collect samples that might one day be returned to Earth. It carries on the legacy of exploration, the quest for knowledge that propels us forward, even when faced with the unknown. These missions have made significant discoveries about Mars. We found evidence of water in its past, glimpsed its dynamic weather, and even detected methane, a gas often associated with life. Each revelation brings us one step closer to answering the age-old question, are we alone in the universe? From the first successful flyby to the latest rovers, our understanding and fascination with Mars have grown exponentially. As we continue to explore, who knows what other secrets Mars holds, waiting to be discovered. What does the future hold for Mars? This is a question that has been on the minds of scientists, researchers, and space enthusiasts for decades. As we step into the future, the red planet continues to be a focal point of exploration and scientific discovery. The future of Mars exploration is brimming with ambitious plans. NASA, along with other international space agencies, has on its agenda several human missions to Mars. These missions aim to not only explore the Martian terrain, but also to understand its atmosphere, geology, and potential for sustaining life. The journey, estimated to take around 6 months, is a testament to our technological advancements and the human spirit's unyielding curiosity and exploration. But the future of Mars isn't just about exploration, it's also about transformation. This brings us to a fascinating concept: terraforming. Terraforming Mars essentially means modifying its environment to make it Earth-like, a process that could potentially make Mars habitable for humans. Scientists are considering various methods, from releasing greenhouse gases to melt the polar ice caps to creating artificial magnetic fields. While still a concept in its nascent stage, terraforming Mars sparks a sense of wonder and opens up a world of possibilities. Imagine a future where humans could call Mars their second home, a future where Martian soil could bear the fruits of human labor, a future where the red planet isn't just a celestial body millions of miles away, but a neighbor, a sibling to Earth. The potential for human habitation on Mars is a tantalizing prospect, one that could redefine our understanding of life and our place in the universe. The future for Mars, therefore, holds exciting possibilities, from human exploration to potential colonization. As we continue to gaze at the red planet, we are not just looking at a distant celestial body. We are looking at a future that is ripe with opportunities and challenges, a future that could witness humanity's first steps outside its home planet. The future for Mars holds exciting possibilities, from human exploration to potential colonization. Let's take a moment to reflect on what we've learned about the red planet. From its fiery birth in the swirling dust and gas of the early solar system, Mars has captivated our curiosity and imagination. We've discovered that in its youth, Mars was a world not too dissimilar from our own, with liquid water and possibly conditions conducive for life. Fast forward to the present, we've sent numerous missions to Mars, from rovers to orbiters, each contributing a piece to the grand puzzle of the Martian world. They've shown us towering volcanoes, deep canyons, polar ice caps, and much more. Looking ahead, the future of Mars is as intriguing as its past. With plans for human missions and colonization, Mars is no longer just a point of light in our night sky, but a destination. As we continue to explore and understand Mars, who knows what exciting discoveries await us in the future?